So in case someone's not here, I'm recording it. All right. So the rule that I was just talking to you about is product of powers. And like I was saying, when you were in Algebra 1, you did easier ones that were like x to the second times x to the fifth. And you add those up. You add 2 plus 5. So we get x to the seventh. Well, now that you're in Algebra 2, the example we have here is harder because they give you more fractions to deal with. But the rule's the same. You have, if the big number called the base is the same, they're both of 5, you can do this rule. You can take the 1/2 plus the other fraction 3/2. So yep, when you're multiplying, you add your exponents. Yep, so this rule is adding the exponents. It's called product of powers, and you're adding your exponents. Okay, so if you're not great with fractions, that's fine. Grab a calculator. What's 1/2 plus 3/2? 4/2. And that can reduce. 4 can divide by 2. Yeah, so it ends up being like 5 squared, which is 25. Or fit it all in there on the screen.
But we don't multiply the 5s together first?
No. They're the same base. You keep the base. You just have to add the exponents. Now the next rule is called power of a power. And they give you a little example with letters here. When it's like parentheses like that, you multiply the exponents. The base stays the same again. Yep, the big number stays the same. The 3 stays the same. And you have to multiply 5/2, it said there, and you have to times it by 2, by the number on the outside. See, because in the rule, they put like m's and n's, and it just shows mn. So that means like m times n. Whatever those little tiny exponents are, you just times them. So what's 5/2 times 2? Yeah. And that'll reduce. Yeah, it's 5. Like when I see that, when I see a 2 at the bottom of one fraction and then a times 2 right there, I don't know if you all see that or think the same way, but when I see those 2's there, I think, oh, that cancels out. So it's just 3 to the 5th. Now I could get a calculator out. What is 3 to the 5th power? So the answer is 243. Yep. So you just got to take your time, and like when you work these things out, you know, try to look and figure out what rule is it, what rule do I have to do. All right, third one. And try to look how it's different than the previous one. Like this one up here only had one thing, like it only had the big number 3. You know, only one big number inside, and then it has these little exponents that you have to times. But now this new rule has 2 bigger things inside. 2 different bases, like an A and a B, a 16 and a 9. And then the little exponents on the outside. So it says here, like in this rule, you can do A to the M, A to that power, and B to that power. See, A to the M, B to the M. So now we got 16 times 9 to the 1/2 power. So you can do 16 to the 1/2 power times 9 to the 1/2 power. I'm just following how that rule looks. Yeah, it's like this 1/2 power goes with each thing inside. A 1/2 power is the same as square root. So do you know what square root of 16 is? Yep. What's the square root of 9? 3. 4 times 3, 12. Yeah, 16 to the 1/2 power is 4. 9 to the 1/2 power is 3. 4 times 3 is 12. Yeah, a lot of little rules to remember. Now this next one's negative exponents. You did these in Algebra 1 also. I can write one on the board. Like if you had x to the negative third, you would rewrite it when you were in Algebra 1. You wrote it 1 over x to the third. If it's a negative exponent, it's like it gets moved. You have to move it. Same thing if it would be like, what if it would have been 1? What if it would have been like a fraction to start with? Like that, then you would have to move it up. It's like moving the location of it up or down to get rid of the negative. You're trying to get rid of the negative exponent. So you move it to get rid of the negative. So this rule is showing that a to the negative m, see, so they wrote 1 over a to the m and moved, so it's not a negative anymore. They're trying to get rid of the negative. So yeah, like the negative exponent, the point is to get rid of negative exponents. Get rid of the negative by moving it. You know, you try to make a little note or something for yourself, because that's the one that seems to trip people up. You're trying to get rid of the negative. You just move the location of it. If something's negative, you move it down to the bottom of the fraction. Or if it's already in the bottom of a fraction and it's a negative, you can move it back up. So this has 36 to the negative 1/2 power. So I'm going to put 1 over 36. And now it's not negative anymore. Now it's just 1/2 power. See, I like moved it down to the bottom of a fraction. So then what's 36 to the 1/2 power?
1/6.
Good job. Yep. It's like, that means square root of 36, which is 6. Yep. So it's 1 over 6. That's the answer. The next one you can try on your calculator too. You could try what's 216 to the 0 power. It's 1. Anything to the 0 power always equals 1. No matter what it is. No matter what it is. So this next one, they're taking like all of this to the 0 power. So the answer is 1. You just put 1. That's it. No matter what it is, this whole thing to the 0 power, so it's 1. Okay, then we're getting to, there's some fraction ones here. This one's called quotient of powers. Yep, so this one's like a division one. Look at the little rule with the A, with the letters like the A's and the M's and the N's. Look what they do on this one. What do they do this time? So the M and the N, do you see what they're going to do? They're going to subtract M minus N. Whatever these power things are, you subtract them. When it's a fraction, you subtract the exponents. So this has 4 to the 5/2 power and 4 to the 1/2 power. So we're going to take the 5 over 2 part minus the 1/2. See, like the little exponents? Maybe I can circle them or something. You're subtracting those. This rule, this quotient of powers, you're subtracting. Subtract exponents. So write whatever you need to on this paper, you guys. It's your notes. You know, I'm trying to, I didn't write something next to every single one. But yeah, the first one was adding exponents. This one was multiplying exponents. Power of a product. It's like you're doing the power on each thing. Write whatever you need to on this note page. So now we're on this fraction one. You subtract the exponents when you have a fraction thing. Okay, so see, it's like 4 to the 5/2 over 4 to the 1/2. So you just subtract the 5/2 minus 1/2. So grab a calculator. 5/2 minus 1/2, or do it by, use your brain power. 5 minus 1 is 4, so 4 halves. But 4 halves is the same as something. 4 halves is the same as what? 2, yep. 4 divided by 2 is 2. What's 4 squared then? What's the answer? 16, yep, good job. See, these aren't too bad, are they? Just lots of fractions to keep track of. Okay, now this next one. I hope this part helps you because it does just kind of show you what the rule is going to do. Even though it's all these letters, it's supposed to try to help you see, like, oh, see, it's just this top thing with this little power on it and the bottom thing with that same little power on it. So hopefully all these letters, hopefully that helps you to see what's going to happen. And then we try it with an actual problem. So what do you think is going to happen on this one? Yep, 27 to the 1/3. See, good job. You got it. 64 to the 1/3. It's like that power on the outside is going to go with each of the things in the inside. Yep. So now figure out on a calculator, if you don't know it, use your calculator. What's 27 to the 1/3 power? Yeah, that's 3. Good job. It's like 3 times 3 times 3 makes 27. And what's 64 to the 1/3 power? Yep, 4. Okay, this next one's kind of tricky. It's just kind of weird. It's kind of a weird one. You kind of have to think like we were doing earlier, like I was showing you earlier in class, where you can break numbers apart. Like earlier in class, I was showing you 16. That breaks down into a bunch of numbers. That's what you have to think about on this one. They're trying to show you that you can break something apart into 2 different radicals. And if like this says cubed root of 135, it's like you have to take this 135 and think what goes into it. What numbers go into 135? Yeah, it ends in a 5, so that's an easy choice. 135 divided by 5. 5 that'd be 27. So they're trying to tell you that since this 135 breaks apart into like 5 times 27, so you could separate this and write cubed root of 5 times the cubed root of 27. It's like just breaking 135 into 2 things. See? 5 times 27, you were just saying. Well, do we know the answer for cubed root of 5? Does that come out nice? If you try it on a calculator, it doesn't come out nice. It's a decimal. We're not going to put decimals. So you just leave it like the cubed root of 5. You just leave that. But how about cubed root of 27? Yeah, so your final answer is going to be 3 and then the cubed root of 5. We did stuff like that when we were simplifying radicals. It's like we know the answer for this is 3. I'm just going to highlight it to kind of see like we solved part of it, but part of it we couldn't solve. We just leave it. Finally, the last one on this chart has a cubed root of 8 over 27. You can do cubed root of 8 and cubed root of 27 like each separately. That's how the little directions over here are kind of showing it. So here's this one's again, hopefully not too bad. Cubed root of 8, that's 2, right? Cubed root of 27 is 3. Done. So most of these came out. They were weird problems to start with all these like fractions and all these radicals. But you can see all the answers came out pretty normal. 25, 243, 12, 1, 16, 3/4. This was the only kind of weird one. This one still had a radical in it. But most of them came out fairly normal. A few fractions, but yeah, you simplify them as much as you can. All right, so we're off to a good start on this kind of it's the hardest thing is like figuring out, what do I do? Like, which one is it? Is it this kind? Is it this kind? You have to figure out what kind of problem am I dealing with. I mean, try to just look at these notes and like, if you have a fraction in your problem, then try to look at these fraction ones and think like, oh, it's that kind with the, when we've subtracted the exponents. Or we're going to do just a couple more things at the bottom here, and then we'll have you guys start trying some. We're going to do the back of this next time. So there's a lot to this lesson, so we're just going to get started. We're just getting started on it. So the thing is, like we're saying, is like try to figure out, what do you do? So the one at the bottom corner here, 2 to the 3/4 times 2 to the 1/2. Do you have any idea? We had all these names of these up here, all these names of these properties. Do you have any idea what kind this one is? Awesome job. That's good. It's actually like this one. Like I was saying, you kind of learned that in Algebra 1, but we just take it a step further in Algebra 2. It's called a product of powers. Good job. It's like the first one that we did on the example at the top. It's a product of powers. And on that, we want to add the exponents on this kind. So I'll just make little notes for you to help you out. So it's 2 to the 3/4 power times 2 to the 1/2. So the big number 2 stays the same. You just have to add the 3/4 and the 1/2. You have to add the little powers. You can do a calculator and add that, or you can get a common denominator. Like common denominator is 4. Like 1/2 is the same as 2/4. It ends up being 2 and 5/4. If you use your calculator and try to add that, 3/4 plus 1/2, your calculator is going to say 1 and 1/4. See, if I add it, 3/4 plus 1/2. I get 1 and 1/4. That's a mixed number, 1 and a fraction. If you want to change it to improper, you can. You hit second and the fraction key again, and it comes out to 5/4. 1 and 1/4 is the same as 5/4. Yeah, again, it's like a lot of keys on the calculator to know how to run it. You know how to run your calculator, because you do 3/4 plus the 1/2, and it comes out to 1 and 1/4. Well, then you have to know how to change that to 5/4. Some of you are really good with fractions, so that's awesome, but just trying to go over those difficult things for some people. Okay, next one. 3, the top number is just a normal 3, so it's like 3 to the 1st power. The bottom part has like this 4th root of 3. Is there a way to write it with a power instead of like in a box? Like this is called a radical, and I want to write it so instead of a radical, like a fraction here. Remember how to do that? Yeah, it's 3 to the 1/4 power. A 4th root is like 1/4 power. So then this is a fraction one. This one, if you look above, we did one like this. Do you know the name of this kind? Or do you know what to do with these little? Good job. It's quotient of powers. Quotient of powers. So what are we going to do? Yep, you're going to subtract the exponents. So it helps if you can look above on the sheet and figure out which kind it is. So you're going to take 1 minus 1/4. See, because it's 3 to the 1st power, and then you're going to subtract the 1/4. What's 1 minus 1/4? Yep, so it's 3 to the 3/4 power. Okay, next one. The top number 7, 7 is just like 7 times 1. Nothing really goes into 7. It's a prime number. The bottom number 9, isn't that the same as 3 times 3? 9, 3 times 3. Like 3 squared. I'm just going to write it like that. This one's a tricky one. I'm wanting to do that. I'm wanting to show you that 9 is the same as, like I'm saying, like 9's like 3 times 3. And I'm writing 3 squared in there. Because this one's different than all the, we haven't done one like this yet. It's not in the chart. This is one where we're going to learn how to rationalize the denominator. It's not the same as any of the problems up above, because all the problems up above, like a lot of times the big number was the same, like these both said 4s here. And if they weren't the same, we knew how to do the root of those. We knew what the cubed root of 27 was, or we knew what 27 to the 1/3 power was and stuff. But I don't know the cubed root of 7. It's a decimal. That's no good. I don't know the cubed root of 9 either. It's a decimal. You try it on a calculator. It's a decimal. It's no good. So I know it's a different kind. I just know it doesn't work with any of those rules up above. These numbers aren't the same base. I can't like subtract the exponents. You can only subtract exponents if these would have been the same number inside of here. So it just doesn't work out. So I know it's a different kind. So I'm thinking, if this would have been the denominator number, the 9, if it would have been a number like 27, I could have done the cubed root of 27. So I'm trying to show you that 9 is like 3 times 3. It only has like 2 3s in it. I need 3 3s to do a cubed root. You need 3 of something. So what you do is you multiply by what you need. You multiply by what you're missing. So you have to you need another 3, so I'd have 3 to the 3rd power, so I could do the cubed root of that. So I have to times by another 3. That's the easiest way I can describe it. It's like you times to put in like another, you need another 3 to make it 3 to the 3rd power. So you times by the cubed root of 3, because I need another 3 with this to make it 3 3s, and then I can do the cubed root of it. So you multiply by what you need. So it is kind of weird. Well, the top part, the 7 and the 3, you can just times those. 7 times 3 is 21. So the top part is the cubed root of 21. So now I'm saying the bottom part, if I put this up, now I'm putting that another 3. Now I have 3 3s. That's awesome. Now I have 3. This was 3 squared. I'm putting another 3, so now I have 3 to the 3rd power. So now I know that the cubed root of 3 to the 3rd, that it like cancels out. It's just 3. So hopefully that makes sense. I know it's kind of hard to say it and explain it to you guys. That's the answer. So I times by what I needed. I needed another 3 because I have to have 3 of something so I can do a 3rd root. So I just times by what I was missing. Because then that's 27. 9 times 3 is 27. I know the cubed root of 27 is 3. It's weird. I know. It takes a little getting used to. We're definitely going to have to practice that more next week. I'll have to show you and go through a few more of those kind. Those are hard. Finally, we're to the last one. This last one has a number on the outside. Okay, I bet this one, you might notice there was one up above that's kind of like this. Good job. It's like the one up above. I'll go back up to it. It's like this one. Similar. Yeah, it's like this power of a product thing. Okay, so this one's like a power on the outside. Power on the outside, so you just times, that 3 is going to times by these other powers inside. So it has 5 to the 1/3 power, and then so you just have to times it by 3, the 1/3 times 3. And then you have 7 to the 1/4 power, And you're going to times that little power by 3. It's like distributing that outside thing. It's like pulling that. So what's 1/3 times 3? Good job, 1. And then 1/4 times 3. That'd be 3/4, 7 to the 3/4. So 5 times 7. 5 to the 1st is just 5, right? So 7 to the 3/4. That's how you just have to leave that one. You can't really do anything else with that one. You could write it like that. That's an acceptable answer. Another acceptable answer, sometimes people do it this way, that we've talked about how you could write it as a radical thing, like in the box. The 4 would go outside the box, the 3 out here. You could do like that. You could write it like that. Either answer's fine. I like that's simpler a little bit. This is another step. Both of those answers are fine. They're the same. They mean the same thing. Okay, so I know that was a lot. There was a lot of little rules to go through. First thing we're going to do with that, wait, let me hit this stop on this.